Hi everyone. In today's challenge, we are going to solve this problem. The problem name is minimum speed to arrive on time, and the problem number is 1870. Alright, guys. So first of all, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. Now let's see what this problem is, right? And guys, if you want to have a look on the solution, which I'm going to write in this video, I will share the link in the description. You can go through that particular link and you can find all the solution, right? So now let's see what this problem says, right? So problem says you are given a floating point number r representing the amount of time you have to reach to the office. So guys, we are given first of all one input that is nothing but hour, right? It is a floating point, that means the data type is going to be double, right? Or float. That is clear, right? After that, to compute to the office, you must take n train in sequential order. Now we need to take n train to reach to our office. Simple thing, right? So we need to take n train for office, right? Fine. You are also given an integer array distance, dist of length n, where dist of I describe the distance in kilometer of ith train. So now guys, we are given one array, right? So two things is clear, right? First thing is nothing but we are given one our array, our input, which is nothing but a double float. And second is what we can say this particular dist array. This is nothing but an array in of we can say integer, right? Or it could be anything, but this is going to be array of size length n, right? N is nothing but we can say the number of trains, right? So this is distance will tell us that for each train, what is the distance that train going to cover? Simple, right? So let's say distance array is looking like 1, 2, 4, and again 1. So this zero index is telling us that the zero train means first train is going to take one distance. It's going to cover a one distance only. Second train is going to cover two distance. Third distance is going to cover four distance, and fourth train is also going to cover one distance. I hope it makes sense, right? So this is the simple thing. Now each train can only depart at an integer r. So you may need to wait in between each train, right? Now guys, let's say you have completed the first train and you completed at the time of 30 minutes, or not 30, I will say, let's say 45 minutes, right? Fine. So you have completed the first train journey in 45 minutes, but the second train will depart at the fixed hour. If you have completed the 40 journey in 45 minutes, you have to wait for 50 minutes. It can only start in the next hour, right? So let's say you have completed in 1 hour 45 minutes. So next train will depart at 2 hour only, right? At 2 o'clock, not at 3 o'clock, not 2:15, 2:10. It can only depart at a fixed o'clock, right? 1 o'clock, 2 o'clock, any o'clock, right? Fine. And so we have to wait for some time. For example, if first train takes 1.5 hours, you must wait for an additional 0.5. So we can't start second train at 1.5 hours. We have to wait because that is going to start at 2 hour, 2 o'clock, right? Fine. Return the minimum positive integer speed in kilometer per hour that all train must travel at for you to reach the office on time. Or we have to return -1 if it is impossible on time. So simple thing now, guys, as we are clear with three things, right? So nothing but we can say we are clear with our distance, we are clear with our time, what time we want at minimum time, or we can say maximum time we can take to reach our office. So that is nothing but hour. This is the maximum time we can take to reach our office. Second thing is nothing but how many train we need to take. We need to take n train, that is sure. Third time is nothing but we can say uh, we cannot take a second train if we reach to that particular position, or we can spread that position in a, we can say not fixed o'clock, right? If we have completed our first journey and we want to take a second train, but we are at a time of 1:30 or 1:50, 1:30, 1:45, 1:50, anything, we can't take a second train. We have to wait for the fixed hour, right? Fine. So we are clear with this thing. Now let's see. We need to return the minimum positive integer, means minimum speed which should take let me tell you here. We need to now find a minimum speed, right? We need to find now minimum speed so that we can reach to our office in the given hour, right? And speed should be speed, what? Speed of train, right? We need to find the minimum speed. What should be the minimum, or we can say speed of a train in our case for the given input, so that we can reach to our office it we can say in the given hour, right? In this given hour. So simple thing, guys, we have to just find out the speed of train. What should be the speed of train, right? Simple thing. If we want to reach our office, if we want to reach our office at the given time, or before this given 6 o'clock, right? If we consider the first example, right? So let's understand the example, then you will have a better understanding. I know it's might complex. So here, guys, we are given a distance array 132. So this is nothing but we can say 132, nothing but three train are there. And the first train is going to cover one distance, second train is going to cover three distance, and third train is going to cover two distance, right? We can say 2 kilometer, any unit you can give, right? Now guys, we have to reach to office in between, we can say before, at max 6 hours, after taking at max 6 hours, right? So in before 6, we can say, right? Before 6, right? We have to reach to our office before 6, right? So we should, this train should not take more than 6 hours. So we have to find the speed. What speed should be of train, right? So we have to find the minimum speed, right? So let's see that how we can do this. So what we are going to do, we are going to say, if we take a speed of 1, so it's going to take a 1 unit of time, right? So one distance is going to cover in one, let's say 1 hour. Second train we can start it because it is a fixed hour, right? So we can start second train, and this is going to take a 3 distance, right? So as we have assuming that we are taking a 1 kilometer per hour speed, so we can say nothing but 1 kilometer per hour speed. That means it's going to cover 3 kilometers, so it's going to take 3 hour, plus second is nothing but it's going to cover 2 kilometers, so it's going to take 2 hour. So total hour we are getting a 6 hour. So you can see guys, we can reach to our office to our 6 hour. I hope it makes sense. So we can reach to our office because it's all the trains combining taking a 6 hour of journey, right? And we can say that if our journey is less than or equal to our given hours, so we can reach to our office, simple condition, right? So fine, that makes sense. So this means nothing but we can say our 1 kilometer per hour speed is the minimum speed which a train should have, right? If we increase a little bit, so you know that guys, it will gonna be more than 6 hour, right? And that should not be the possible. That means it's not acceptable to reach our office, right? We will not get our attendance, right? Fine, that makes sense. So now that's clear. So we can say here we can return answer 1. You can see output as well, we have 1, right? Now let's move to the second example. Here we have 1 3 to same time, but the condition is hour should be not 6, now it should be 2.7, right? I hope it makes sense. So we can say our hour should be 2.7. So that means nothing but we want to reach to office before 2.7, or we can say 2 hours 7 minutes. If we are starting at 00, then we want to reach before 2 hour, and uh, you can assume it's 7 in a minute. So what you will get, you can write over there, means it between of that, right? So if we convert into minutes, so if we say uh, what we can do, we can multiply it by 60. So we can say uh, 162 minutes, right? So we want to reach to our office in 162 minutes. That means nothing but 2 hour 42 minutes, right? Now let's see whether it's possible or not. So what we are going to do, we are going to say we are going to take we know that if we take a speed of 1 kilometer per hour, it's not possible, right? It's going to take 6 hours to reach to our office. But if we reduce it by somehow, not reduce it, we increase our speed by 2, then let's see whether it's possible or not. So first train is going to take 2 hours, right? Second train is going to take not 2 hours, so it's going to take 0.5 hour, right? But we have to wait for 1 minute, go for 50 minutes as well, right? Go 30 minutes as well, because it's taking a 0.5 hour. But you know that guys, it's taking a 0.5 hour, but next train can only start at the fixed o'clock, right? So it's not can it's second train cannot start at 0.5 hour only. So we have to wait for 1 hour, so it's going to take totally 1 hour. Second train is going to take what? It's going to take 2 hours, right? Why? Because 2 kilometer per hour, and we want to reach at the 3 distance, so it's going to take definitely for more than 1 hour, and we can't take. We have to wait for that particular one. So we can say if we are doing that particular part, so we are to wait for next train, right? Completely, we can't use 1.3 or something else. We have to complete and take 2 hours, because next train can only start at the fixed o'clock. Fine. The next train is gonna be take only 1 hour, right? Because 2 kilometer per hour and 2 kilometer per hour. So total is, we can say hour is gonna consume over here is 4. But still it's not meeting our condition. We want to reach before 2.7, but we are getting a total 4 hour if we assume the train speed is 2 kilometer per hour. Okay, but let's say we increase it by 3. So now first train is going to take how much? It's going to take 0.333, but we have to take 1 only, because we can't take in float variable. Why? Because next train can only start at the fixed o'clock, right? The second train started at the first o'clock. So now we can see it's going to take only 1, so it's become 2 now. Now third train is going to take now something in between of, we can say it's taking a 3 kilometer per hour speed, and we want to cover 2 distance, so you can use the distance formula. Distance equals speed of time, so you will get nothing but 0.666, right? I hope it makes sense. Fine. So its total combine is taking 2.66. Here we haven't make it 1. Why? Because there is no next train, we can say present, so we don't need to wait for anyone, right? We can say, oh late, this is our final result. So we can say 2.66 is our result. So now let's see whether it's matching our condition or not. You can see our is 2.7, and we are getting we are reaching to our office in 2.6, is slightly less than 2.7, right? So that means we can get our attendance, right? So it is possible. So we can return nothing but our minimum speed of train should be 3 kilometer per hour. I hope it makes sense. You can see output as well, 3 kilometer per hour. Now guys, we are getting a distance 132, and hour is nothing but 1.9. Here it's directly -1, right? You can see its output minus. It is not possible even. So as these train, at least they are going to take at least 1 unit 1 hour, right? because if we take it even 0.1, first range take 0.1, we have to wait for the next train complete hour, right? So it's gonna take complete 1 hour. That second is also gonna take complete hour. But it say that we need to reach before 2, right? In 1.9 hour we have to reach to our office, but it's slightly or because it's completely impossible, right? So we have to return -1. I hope now you understood the problem statement, right? So we have seen three examples and three were really interesting, and we have seen the problem statement. So, but basically it says that we are given two things. First is hour, that the maximum time we can take to reach our office. Second is the distance array. Distance arrays have a distance of each train, that each train how much distance they are going to cover. And third is nothing but we need to find the speed, and that should also be minimum speed, so that we can reach to our office. If it is not possible, so we have to return -1. Now let's move to the logic part. I know it's taking. I'm quite a bit hurry, just because guys, you can watch in a 0.75x if you are finding this video is really fast, right? But believe me, guys, it's I find it's cool, right? Fine. So now, how we can solve this particular problem? What is the logic we should use? So the interesting thing they have already told in our question. That's why I haven't read this line in starting. So see, just try to understand this particular we can say line. Tests are generated such that answer will not exceed more than 10 raised per 7. That means the train speed will not be exceed more than 10 raised per 7, right? And hour will have at most 2 digits after the decimal point. So this hour, like here we have 1.9, so it could be 1.92, right? But it will not be that 1.946. Like, let me show you. It will not be like this. It will be at max 2 digits, right? A second thing is nothing but test. We can say speed should not be exceed more than 10 raised to 7. 10 raised per 7. They have already guaranteed that. Fine. So we can use a simple thing, simple algorithm, which is gonna work. Why? First of all, tell me which algorithm we can use here. I know you have seen in the problem statement, or we can say on the Leetcode platform, that what other algorithm getting used in this problem. But let me tell you, here is going to be binary search. And why it is a binary search? That already I have told you that its answer is not going to exceed more than 10 raised to the power 7, right? And second thing, at minimum speed, what could be? It could be 1. So we have this range now, right? Isn't it? If our we can say our answer is coming 10, we can say our answer is satisfied. Our we can reach to our office in 10 raised to 4 unit of speed, right? When the train speed is 10 raised to 4, then we can simply say, guys, the next numbers which are coming till 10 raised to 7, we can easily reach over there, right? If train speed is 1000 or 10k, right? If train speed is 10k, then what we can say? We can say anything more than this speed will always allow us to reach to office within a time, but less than this speed will not guarantee, right? Okay, so this is the condition, right? If we are able to reach to office in this particular position. But so we have seen this case, yes, we can reach to our office if the train speed is 10 raised to 4. But if train speed is not 10 raised to 4, if train speed is 10 raised to 4 but we still not able to reach to the office, then what we can say? Then that is sure that on the left side till 1 we are not able to reach to the office, right? This is guaranteed. But right side we may reach to office, so we will move to the right side. So just let me tell you a simple example here. So if we reach to office with this particular speed, then we gonna move to the right side, because then we gonna move to the left side, because right side will definitely guarantee that yeah, we can easily reach to the office because its speed is gonna be over more than that, right? But if we not able to reach to the office with this speed, so left side guaranteed that we could not able to reach to the office because it's going to be less than that. So visualization is really important over here. So if you are reaching to the office, right, this is office, and if you're reaching at 10 per, or let's say 2 km per hour speed, if you're running at 2 km per hour speed and you're reaching to the office, fine, that makes sense. Right? If you're running to 2 km per hour speed and you reach to the office, that means, but this is a yes condition. And here, if you increase your speed, you say now I'm running at 3 km per hour. Can you reach to the office? Yes, you can reach to the office because it's already increased that, greater than that. If you're running at 4 km per hour, can you reach to the office? Yes, we can reach to the office, right? But there is no guaranteed that on the if you're decreasing your speed, if you're saying now I'm running at 1 km per hour, can I reach to the office? There is no guaranteed there, right? You may reach to the office, you may not reach to the office, right? So we can say we will move to the left side. We will move to the left side if we are able to reach to the office. But if we are not able to reach to the office, that means nothing but, let's say I'm not able to reach to the office when I'm running at 2 km per hour. So that means if our speed is 1 km per hour, can we reach to the office? Definitely directly no. Here directly no, because even if you are running at 2 km speed, you are not reaching the office. How you can reach to the office when you are decreasing your speed, right? So means left side is directly not possible. But if I increase it, can I reach to the office when I'm running at 4 km per hour speed? Yes, you can. You not yes, maybe, right? So in if the answer is no, then there is a possibility on the right side. But if but there is no possibility on the left side, there is directly no. And in the case of yes, there is a possibility on the left side that you may there is also some speed exit where you can reach to the office, but on the right side there is completely yes, right? So this was the simple scenario. So we are going to see only this condition. We are going to say if we can reach to the office with this speed, so move to the left side and try to check the less speed which can allow us. If we are not able to reach to the office, then move to the right side and try to find the speed where we can reach to the office. Simple two condition only. So now let's move to the implementation part and let's see how we can implement this one, right? So I'm gonna be a browser. So here guys, I'm first of all with the Python. So what I'm gonna do, I'm gonna say fine. First of all, take a length and length of distance. And here we have seen the third example. And let me show you here as well. So this third example directly giving us -1. Why? Because here if you focus here n means length of distance is what we can say greater than our this hour, right? And hour could be in floating number, so we can use a C, right? So if it is greater than that, so we can that return -1, right? I hope it makes sense, right? So if our number of trains or we can say distance is greater than our we can say seal of hour, then we can directly return -1. Fine. Now what we are going to do, we are going to use a binary set. We are going to say low initially going to be nothing but we can say 1 and high is going to be nothing but 10 is to a 7. So how we can write? We can write directly like this. Then we are going to say while, let me write while low is less than or equal to high, and we can say find a mid, which is going to be nothing but low plus, let me use a low plus and high divided by 2, and we can say find check now if possible with this mid is nothing but our speed, right? So this is speed. If it's possible with this mid, then what we are going to do, we are going to move to the left side. So low is going to be nothing but not low, high is going to be nothing but mid minus but, right? Else if it is not possible, so we are going to move to the right side. So we can say low is going to be nothing but mid plus 1, and then we can simply return low. Simple thing, right? Now this possible function, let's define that function, right? So I'm going to say define. Okay, I have given much space. Define possible. So what this function going to do? This function going to take a speed, right? Fine, and we're going to say fine if it is taking a speed, cool. Now we are going to traverse all the distance array, all the tail, and try to fit this particular speed over there, right? So we are going to check whether with this speed we are able to reach to the office or not, right? So what I'm going to do, I'm going to say for I. First of all, let me show you a shortcut way. Return sole, return sum, and here we're going to say fine. What it's going to be? It's going to be seal, and we can say distance of I divided by speed. I'll show you what I'm doing. If our we can say I is not equal to, if I is not equal to, we can say n minus 1. Else we are going to say distance of I divided by speed, and it's going to work for I comma, we can say what we going to do, we could say okay, for I in range of n, right? For I range of n, and we can say after that what you can do, you can say it should be equal to less than equal to ours. So I know you did not get this one. What is this meaning? That let me show you here. Just I'm going to comment this particular line and I'm going to same implement over here, so you can understand both of the things. So I'm just traversing of length for I range of n. I'm just saying if our distance of I, not if, I'm going to say first of all take a total value which initially 0. So I'm going to say total plus equal to distance. You have to use a seal value, means seal, and here we're going to say distance of I divided by that speed, and at the end we can say but fine. After that we are going to say total plus equal to distance of I divided by speed. Here we are not using a seal. Why? Just because we know the last train, we don't have to wait for the next train, right? And then we can simply returning a total should be now equal to less than hour, right? Now let's see whether that's working fine or not. So simple thing guys, these both line, this one double line which I committed and this whole thing are same, right? So we got an error which is nothing but, well, let's, so we can't use this thing here, so we have to say nothing but like this. Fine, now let's see. So you can see all the test case not passed. Why is it so? So we are getting answer 2, but we should not okay, fine. All right, so we are saying total 0, and for a range of n we are just adding all the things, fine. So that means that we have to use -1, right? So because we are not taking the last number here. Now let's see, but still it's not passing. And all right, so what is I here? I is something else, right? I is not there. Let's see now. Hopefully it should pass, right? You can see guys, all the test case pass. The reason is guys here now let me tell you this two line. So here also I'm doing the same thing, here also I'm doing the same thing. I'm just saying that for this speed, first of all take all the trains except the last train. Why? because rest of the day I'm going to take the complete hour, right? Even I'm completing that journey in 0.5 hour, but I have to take the 1 hour, right? So I'm doing the seal. Mat.seal is going to take the top value 0.5, it's going to consider 1, 1.3 it's going to consider 2, right? But at the last train, for last train n-1 train, I'm not going to do that part because I don't have to wait for the next train. I can directly reach to the office from that particular position, right? So I'm not doing the seal operation over here, seal method. And after that one's done, I'm just checking whether my total speed, this total is nothing but the speed which took in that particular, is total is nothing but our hour which took when all the train were running at this speed, right? So if it is less than our hour, means the given hour, then we can say directly we can reach to this, so return true. But if it is not less than that particular hour, so return false. So the same thing we are doing here. So I hope it makes sense. So let's try to submit this code and it's working fine or not. Let's see that part, right? So I hope it should work, right? So let's see that. So you can see guys, it successfully got submitted. So we have successfully submitted with this one. Now let's move to the next programming language, which is C++. Now let's quickly do this, right? We have invested a lot of time here. So what I'm going to do, I'm going to say int n is nothing but, let me just do distance of length, or we can say size. And here we are going to say fine if low is going to be nothing but 0 or 1, high is going to be nothing but 10 is plus 7, so 1 is 7, fine. And here we are going to use a while. Low, we can say low is less than equal to high, and here we're going to say find a mid is going to be what we can say low plus high divided by 1. And here we can say if possible for this mid, so we have to pass here distance as well, hour as well, n as well, mid as well, by because using a not a nested function here. So if it is the case, so you have to move to the left side, but if it's not the case, so you have to move to the right side, and then you have to return a word low. Now let's define this function, which is a possible function. So I'm going to say bool possible, and the name argument is going to take first of all vector int. Let me use a vector. It should also take a nested function, right? Then it should be easier. And it also take hour. So hour should be in double, right? So we can use a double hour. Fine. And we can say our n, and we can say mid, right? Fine. Mid is nothing but our speed. So let's take it as fine. Now we are going to say nothing but first of all one thing, that is nothing but we can see if not, if we can use a directly double total as well. So both make sense, right? So double total is going to be initially 0, 0.0, anything you can give. Right, after that we can say for int I is equal to 0, I less than n minus 1. Why I don't want to take the last int here. So I'm going to say total plus we can say equal to, first of all use a math, not math, we can use directly seal. So we have used directly seal here, and there we are going to say distance of I divided by s, right? And after that what we are going to do, we are going to say fine, but it's not going to work, right? We have to use a, if that number is not in float, so we have to use multiply 1.0, right? Fine. Now at the end for last int we are going to say total plus equal to, so we are going to say 1.0 multiply the distance of I divide not I n minus 1, and here we can say slashes. So we can use slashes here, fine. And after that we can return total should be less than equal to hour. Fine. Now let's see whether it's going to be fine or no. And I hope guys it should work. We haven't used a base condition yet. That's also we need to use, right? So let's make it a use of base condition. So we can say if our distance of I, right? So if our distance of that particular I, or we can use n only, right? If n is greater than our c of our hour, so we can directly return minus 1. Now let's see. You can see all the rest is passed. So let's try to submit this code as well, and I hope guys it will also gonna work. So you can see guys it successfully got submitted. Now let's move to the next one, which is nothing but Java. Fine. Here let's first of all define a function. It take a lot of time, right? Boolean and possible, and we can say the name is going to be distance. Int, not int, we have to use a double hour, and we have to use int speed, right? And before that we have to take n as well, and then speed. Fine. We are going to say double total initially is going to be 0.0 for int I is equal to 0, I less than n minus 1, and I plus plus. Here we are going to say total plus equal to, we are going to use a math.c, and here we're going to use 1.0 into distance of I divided by s, right? At the end we are going to say find total plus equal to math root. No, we don't need to use a seal here, we can just say 1.0 into distance of I divided by not I n minus 1 divided by s. Fine. At that we can simply return total should be less than equal to hour, right? If it is the case, then you have to return true, otherwise false. Fine. And here now in this function, main function, first of all we have to calculate the length, distance length. We have to check if n is greater than math.seal our hour, so we have to return minus 1. It's not possible. Then we are going to say fine. First of all, let's define a low. Int low is 0, not 0, 1. High is going to be nothing but 1 is 7, right? Fine. And here we're going to say while low is less than equal to high. So what you are going to do then? You are going to say find mid. So we have to find mid. Low plus high. We can use high, and here we can divide by 1. Fine. Once we found a mid, then what we are going to do? We are going to say fine. You find a mid. Check whether it is possible or not with this speed. So if possible, for this we can say distance, because after distance we have to pass hour, then we have to pass n, then we have to pass mid, then you have to say what you have to move to the left side. High should be equal to mid minus 1, otherwise you have to move to the right side. So we can say low should be equal to mid plus 1. At then you have to simply return, we can say low, right? And you have to use a return node return. Now let's see whether it's working fine or not, or we have done any mistake. So let's check that part, and you can see we have done definitely a mistake, right? So what we have done, we have to use an int here. Now let's see. You can see guys, all the test case passed. So let's try to submit this code, right? So I hope it will also gonna submit. So you can see guys, it successfully got accepted. Fine. Now let's see. I'm with a JavaScript now, and in the JavaScript, what we are gonna do, we are gonna say first of all, let's define a function. Or before that, let's calculate the length of distance, and let's set a base condition. If our n is greater than math.c of our, then we are written -1. Fine. And here we're going to say while, not while, we have to use first of all function. Const function in what we can put a possible only. So it's going to take one argument speed. As we are using a nested function here, we don't need to pass distance, hour, and anything else. Okay, so we are going to say fine. Let total is going to be 0.0. For int, let me write 4 int is equal to 0. I less than, what we can use? We can use n minus 1, and we don't need to use int here. It's JavaScript. It's use let. Fine, n minus 1 and I plus plus. Fine. And here what we can do, why I'm using this, here what we can do, we can say total plus equal to, and we can say what we can say total plus equal to math.c, and here we can pass distance of I divided by s. Fine. At the end what we are going to do, we can say total plus equal to math.c. No, at then we don't need to use a c, we just use distance over n minus 1 divided by s, right? And we can return total should be less than equal to our. Here we can use another method as well, filter, but it's fine, right? After that, what we are going to use, we can say let low is equal to 0, not 0, 1, and high should be equal to what we can say 1 e raised to 7, right? Fine. So 10 raised to 7 is high. Now we are going to use a while low is less than equal to high. So what we can do now here? Here we can say find a mid, right? So let mid is nothing but low plus high divided by 2. Once this is done, what we are going to do now? We are going to say find you found a mid. Now check if it is possible or not. So possible with this mid. Then what you're going to say? You're going to say make high should be equal to mid minus 1, move to the left side. Otherwise, else low should be equal to mid plus 1, move to the right side. And then you can simply return low. Now let's see. I hope it should work, right? Let's see. Okay, it's taking a time. And do we have something new? It should not take this much time, right? So I think it's time complexity error. No, I got a wrong answer. Why is it the case? So 1000. Oh, alright, so we have to debug this one. So we are using n minus 1 distance and divided by s. Fine. So if possible with this, then what we are going to do? We are going to say the speed total is this much. Total should be less than equal to our r. So we can say for 0 I less than n minus 1 I plus plus. Total should be math.c. So we are adding this one, and we are saying that okay, low plus I divided by 2, 1 is for 7 as well. If it is possible, then you have to do this. High should be equal to mid minus 1. If it is not possible, then you have to do this. It's cool, fine. Life. Let's see what we are getting for the next one. Okay, so it's not running even there, right? So if low is less than high, so what we are doing nothing but this much part. So let's see what's the issue we are getting over here. 1 is for 7, right? So it's completely this one, right? So I think we are doing a little mistake over here. Okay, so let's try to debug this one, right? So what I can do, I can simply say console.low. We can say low, and we can say high. So something, can you try to figure out this one, what we have missed over here? We have done something wrong over it, right? So it's run. and for our console low is nothing but low is 1, so it's keep incrementing to 5000, right? So it's incremented this one fine, but it should not increment with this now, right? So I think some issue in this particular part. We have total which is 0.0. Now we are incrementing with math root cell distance of I and divide by speed, right? So we are dividing with this particular speed, and this speed is nothing but this mid, fine. So it should be greater than that, right? Total should be less than this much part. So I think some issues over here. Console.low our line. I don't know why we got this error in JavaScript. So what we got here is nothing but 6. We got 6 hour, right? So fine. It's not hour. What I am doing here total, right? So I don't think it should give this much, right? So what I got 2.04, and which is less than our hour, right? So if this is the case, then this is less than our hour, it should return true, right? So if it is returning a true, then we are moving to the left side. So high should be equal to now mid, but it's not doing that particular part. So you can say if possible of mid is written true. So what we can do, just give me a second, guys. I have to check one function whether this function is low or not. Alright, so we have taken this much. So I think everything is working fine, right? Total plus equal to distance of n minus 1 is slash s. And the issue is here, guys. So we have to return. Really sorry for this. Let's see now. I don't know why I'm that much silly, right? Now let's try to submit this code as well. So I hope guys you understood this one. So whatever the issue, we are not returning that one, and we are assuming it should return, but like Ruby does. So now you can see, guys, it successfully got submitted. So we are done with the implementation of Python, C++, Java, and JavaScript. I hope you understood all the implementation. If you have any kind of problem understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.